In the next set of videos, we'll be looking at the advantage the parallel connections have over the series connection. So there are 5 main points that I've concentrated on, and I have made 5 different videos. And end of it, I have summarized all these different points, 5 points, and I think I have added one more point so that you guys can write that in your exam. Okay, so all this is for your understanding. And end of it, I have a set of videos that will help you understand the overall answer. Okay, so let's begin with the first one. In series connection, when one component fails in the circuit, the entire circuit is broken. In parallel circuit, failure of one component will not affect the other component's current supply. It's simple. See, here I have a series connection. Here I have a parallel connection. How can we tell that? So this is your node connected to your positive end. This and this are connected, right? And there's a single node shared between these two. And you have a negative node being connected to negative end. Okay. So you can clearly see this is series connection connected LEDs. These are parallel connected. So I have one node common and the second node are common at the ground. Okay. Both are connected to the same ground. That is the same negative terminal, right? So the second one is shared over there. Why is that I have connected at 2 different places for different experiments I've done so. If not, I could have just connected over here and you could have seen 2 nodes being shared directly. So now what I'm trying to tell is if one of it stops working, right? If one of it happens to fail, okay? So I think that looks good. Yeah. If one of it fails, the other will also stop working. In this, if one stops, other will not stop. It will continue to work. Okay. So that's the advantage of parallel over series. Failure of one component will not affect other components' current supply. So the reason is quite simple. The circuit won't be complete, as simple as that. You have this positive end, current will come like this, it will go in this way, and it won't have anywhere else to go. So basically it stops. There will be no continuation. While for this, I have current in this way, and it will go towards negative terminal over here, as you can see. It is connected to this, and yeah, the circuit will be complete. Got it? So the reason being, the circuit won't be complete over here. This will be an open circuit, and this will be a closed circuit. Okay. So let's see this practically. What will I do is I'll just basically remove it. I won't damage it per se. I'll just remove it. It's all because if it's not working, it's as same as removing it altogether, is it not? So I'll remove this LED and this LED if I'm right. One of the LEDs I'll remove from each. So you can see what happens later. So now you can watch the video. Right? You clearly saw that this creates an open circuit. So the entire circuit switches off while this creates continue to have the closed circuit for different components. You can have any number of LEDs. Okay, over here too and here too. It's the way it works in series and the way it works in parallel. It differs a lot, and I just have 2 over here, but you can imagine any number of LEDs. If one fails, everything is gone. Here it's not so.